Only 3 interstellar visitors have ever been confirmed in our solar system. The newest is 3I Atlas, an icy body from another star that is sweeping through on a one-time hyperbolic path. In December, it reaches its closest distance to Earth, and that milestone raises a practical question. What should you expect to see, and what are scientists hoping to learn while it is still within range of our instruments? Start with the big picture. Interstellar means the comet was not born in our own distant Oort Cloud. Its orbit is not a closed ellipse, but an open curve. That shape, combined with its high inbound speed, marks it as a traveler from beyond the Sun's family. Trajectory solutions built from many nights of astrometry indicate that 3I Atlas safely misses Earth by a wide margin. It is a visitor, and then it is gone. Now, the timeline. The comet reached perihelion in late October 2025 at roughly 1.4 astronomical units from the Sun, just inside the average orbit of Mars. After that turning point, it moved outward on the far side of the Sun from our point of view. Through November, it emerged into the pre-dawn sky, and by December it is better placed for northern observers, although still distant and faint. Here is the key number for expectations. The closest approach to Earth falls around Friday, December 19th, at a distance near 1.8 astronomical units. That is about 269 million kilometers. At that range, sunlight is already weaker than at Earth, and whatever the comet reflects or emits must spread across that huge gulf before it reaches your eyes or your camera sensor. The inverse square law is unromantic, but decisive. Distance and viewing geometry set a hard ceiling on brightness. So, what will you actually see in December if you try to find it before dawn? A realistic target is a small telescope view under dark skies. Think of an 80 to 150 millimeter refractor, or a 6 to 8 inch reflector at low to medium magnification. Expect a softly condensed patch with a faint fan. The comet's apparent motion will look like a slow drift rather than a theatrical streak because the flyby is distant. Binoculars may tease a hint under excellent conditions, but most casual observers will need the light gathering power and contrast control of a telescope. Finding it is easier with landmarks. The track carries 3I Atlas from Virgo into Leo through December. In the second week, it crosses the boundary into Leo. Late in the month, it slides a couple of degrees south of Regulus, the bright heart of the Lion. That proximity to a first magnitude star makes star hopping straightforward. Use a wide-field eyepiece to center Regulus, then step south to frame the subtle glow of the coma. Planetarium apps and online ephemerides powered by JPL Horizons can give exact coordinates for your location and date if you prefer to punch in numbers. If you image rather than view, plan short exposures and align on the comet rather than the stars. Stacking with a comet-tracking solution keeps the nucleus sharp and allows the faint outer coma to build in your combined frame. Do not expect a photogenic streamer stretching across the sky. The phase angle is modest. The comet is far from Earth, and the dust is not heavily backlit from our vantage point. You are chasing quiet detail rather than spectacle. Why then are professionals mobilizing a global set of instruments for an object that will be challenging for casual observing? The answer is that interstellar comets are time capsules from other planetary nurseries. With only 2 prior examples in the books, each new visitor fills in a blank square on a very small matrix. Early in its approach, the Swift Ultraviolet Telescope detected OH, which is a proxy for water release. That signal at large sun distance points to sizable icy grains lofted into the coma. Additional infrared observations indicate a CO₂-rich gas mix compared to many solar system comets. Those measurements together suggest that 3I Atlas formed in a very cold region of its natal disk, well beyond the line where water and carbon dioxide freeze with ease. Comparisons matter here. The first interstellar object, 1I or ʻOumuamua, showed no coma and remains an outlier in composition and behavior. The second, 2I or Borisov, was exceptionally rich in carbon monoxide. 3I Atlas appears to be yet another recipe from the galaxy's kitchen. By constraining the relative amounts of water, carbon dioxide, and carbon monoxide, and by tracking how those ratios evolve as sunlight changes, scientists can test models of how other stars build comets and where in those disks the building blocks freeze out. All of that science sits beside a reality check for the public. Brightness surprises do happen with comets, but distance and geometry usually win. At 1.8 astronomical units from Earth, the comet is simply not positioned to become a broad daylight attraction or a naked eye wonder across cities. Some striking images you may see online use false color or narrow band filters to isolate specific gases. Those visuals are scientifically useful, but they do not represent the view at the eyepiece. Treat bold claims of dramatic color shifts or sudden brilliant flares with skepticism, unless they are backed by observatory data and updated ephemerides. Even without fireworks, December brings a handful of practical moments. The early part of the month improves placement before dawn for the northern hemisphere as the comet climbs into Leo. The date of closest approach around the 19th is a sensible window for imagers who want the minimum Earth distance and gentle tracking rates. The pass south of Regulus near the 27th gives everyone a useful celestial signpost and an easy hop through a low-power eyepiece. None of these dates implies a sudden jump in brightness, but each helps observers plan a realistic session. What might change during December that is interesting scientifically? As the comet recedes from the Sun, fresh spectra and photometry can reveal how the outgassing mix shifts on the outbound leg. Astronomers watch the balance of dust to gas to see whether the coma remains gas-dominated or transitions toward a more typical dusty state. They map jets or fans that hint at active regions on the nucleus. They measure tiny non-gravitational forces caused by outgassing that can slightly tweak the orbit solution. Renewed astrometry during the December and January window helps lock those terms down. There is also value in the broader planetary defense context. The official line from NASA is clear. There is no impact risk. The minimum Earth distance this apparition is around 1.8 astronomical units. That separation is far larger than the Sun-Earth distance. Objects like 3I Atlas are a reminder that the solar system is open to the galaxy, but they are not automatic hazards. The risk discipline pays attention, computes, and then moves on when the math says all clear. If you plan a dawn session, manage expectations and lean into the subtlety. Choose a dark site, allow your eyes to adapt, and use gentle, averted vision to coax structure from the glow. If your skies are hazy or bright, imaging may give you a better chance than visual work. Keep shutter times short enough to avoid smearing, stack many frames, and try both broadband and narrowband approaches if your gear allows it. The goal is not a viral showpiece, but a clean record of a third interstellar wanderer threading our sky. For those who like numbers at their fingertips, ephemerides from JPL Horizons will give right ascension, declination, Earth distance, Sun distance, phase angle, and predicted rate of motion for any minute you choose. Public observing pages that draw from those solutions can generate finder charts and visibility windows specific to your location. With that data in hand, you can plan whether to set an alarm for the second week of December when the comet rolls fully into Leo, whether to target the morning of the 19th for a closest approach run, or whether to wait for the simple Regulus hop late in the month. As the calendar turns, keep an eye on professional updates about composition. Instruments such as SWIFT in the ultraviolet and large ground-based spectrographs in the optical and infrared can report changes in gas ratios and dust production. If a jet rotates into a better Earth-facing view, coma structure may sharpen. If outgassing wanes faster than expected, the light curve may flatten or fall. None of these developments will transform the visual experience for most observers, but they will feed the larger story of how other planetary systems build and eject icy remnants. In the end, the meaning of 3I Atlas is quiet but profound. It is only the third confirmed example of an object formed around another star that we can study up close. Its trajectory is well constrained. Perihelion arrived in late October. The closest approach to Earth arrives in mid-December at roughly 1.8 astronomical units. There is no hazard. There is a modest window for backyard telescopes in the pre-dawn sky as the comet slips from Virgo into Leo and past Regulus. And there is a golden month for scientists to measure gases, dust, and faint forces that refine our understanding of how solar systems come to be. If you step outside for it, think of the distance your photons have traveled and the time the nucleus has spent between stars. Think of the diversity implied by ʻOumuamua, Borisov, And now Atlas, 3 objects and 3 distinct chemical stories. Our neighborhood is open. The galaxy occasionally drops a postcard in the form of a cold, fragile wanderer. December offers a chance to read it with patience and with realistic expectations, and to add one more line to the growing ledger of worlds forged under another sun.